Okay, so with the formulas that we've had so far, we have never solved for rate or time. You're either solving for A or P, but not rate or time, and it's because it's a little bit more complicated. So let's start off with A equals PER to the T, which is PERT. Okay, if you want to solve for R or T, okay, missing rate or time, it's an exponent, okay? You have to try to make the exponent come down to become a coefficient. So I'm going to do this in some easy steps, okay? I'm going to write the steps out. The very first thing you want to do is you want to isolate the exponential expression. Which means you want to get e to the RT by itself, or 1 plus r over n to the nt by itself on the left or right side, okay? Then the next thing you're going to do is you're going to take the natural log of both sides. You're going to take the natural log of both sides. Okay? Now the natural log is a type of function. You have exponential functions and its inverse is a natural log. And what this does is it allows, let's say for example you have the ln of e to the rt. It allows the rt to come up front as a coefficient. Okay? Now, what's so great is you have ln of e, so the rt came up front, and you still have ln of e. Well, the natural log of e is just 1, so you're really just left with rt, and you can solve for either variable. Okay? Same thing if you have 1 plus r over n to the nt. Let's say I wanted to solve for t. If you want to solve for t, you have to get it to come up front, which means you're going to take the natural log. Okay, now what that does is it brings those exponents up front to become a coefficient. So now it's going to become nt times ln of 1 plus r over n. And so now there's no more exponents. These are coefficients up front, and then you can solve accordingly by dividing. Okay? So then the very last step is to solve for the appropriate variable. Okay, so let's try a problem. Let's say I want you to use the continuous compound interest formula. So you know that it's going to be compounded continuously. To find the indicated value. I'm telling you that A is 95,000. P is 77,411. R is 9.1%. And I want to know what T is. Okay? So I know the rate is 9.1%. I know that I currently have $77,411. I need $95,000. So with this account that's 9.1% compounded continuously, how long is it going to take me to get this money? Well, our checklist, this is all good, good. We know we have to change this over to 0.091, okay, and we know that we're compounded continuously. Now, the formula is going to be A equals PER to the T. So I have 95,000 equals 77,411. E, we don't know T, but we know that R is 0.091 T. Now the very first thing, you have to get the exponential expression by itself, which means I have to get E, whatever it's raised to, by itself. Well, this is 77,411 times that. So we can go ahead and divide by 77,411. That's gone. Remember to be very careful with how many decimal places you take. I usually take about 4 or 5, so 1.22722 equals e to the 0.091 t. So now we're on step 2. So step 1 was to isolate the exponential expression. Step 2 is to take the natural log of both sides. Okay, now why did we do that? Because now that we've taken the natural log, the exponent can become a coefficient. So this is going to become the natural log of 1.22722 equals 0.091t natural log of e times the natural log of e. And I told you that the natural log of e is just 1, so that's gone. So now I have the natural log of 1.22722.091 times t. I can divide by 0.091. That's gone, and now t is isolated. So t equals this. So you just put that into your calculator, and your calculator should have a natural log button, and it'll approximate how many years that is. And when I put that in my calculator, I get t is 2.25 years. So about 2 years and 3 months. That's how long it would take me to get the desired amount of money. Let's try one more. Let's say that I wanted to use the compound continuous interest formula to find the indicated value. So you know that you're compounding continuously. So we know we're going to use PERT again. I'm telling you that A is 15,416. P is 11,300. T is 60 months. And I want to know my rate. Okay? So go ahead and pause it, try to figure this out yourself, and then come back and see if you got the correct answer. Alright, I'm going to check my checklist. Dollars, 60 months. Oh, got to do a quick conversion. I know I have 60 months. In 1 year, there's 12 months, so that's 5 years. Okay, and then we're going to go ahead and look for rate. My formula is A equals PER to the T power. So I have 15,416 equals 11,300 E to the 5R. Okay, we have to isolate the exponential expression. So I'm going to divide both sides by 11,300. That's gone. I get 1.36425 e to the 5r. Now, to get this to come down, the exponent to come down, I have to take the natural log of both sides. Okay, put some room up here. Hopefully you got that down. Okay, so now what happens is this exponent can come up front to become a coefficient. So I have the natural log of 1.36425 equals 5r natural log of e times the natural log of e, which we now know that's just 1, so that's 5r. Divide both sides by 5, and you will get r. So I get r equals 0.062129, and it wants me to round to 3 decimal places. Now remember, you have to change it to a percentage first, because that's how you present it. So I'm going to move it 2 times. So I have 6.212. That's a 0, which means it's going to stay the same. So your answer is 6.212%. And there's your answer. But what if it's not compounded continuously? What if I had a problem that says, how long will it take? Will it take 5,000 to grow to 15,000 if it's invested at 7% compounded monthly? Okay, so how long, we're obviously looking for t. So that's the variable that we're going to be solving for. 5,000, that's your p, and it's in dollars. 15,000, that's your a, right? I'm just kind of doing my little checklist here. I see 7%, so I know that's going to be 0.07 is my r. Compounded monthly means that my n is 12. Okay, so this is just like little things that I'm highlighting as I'm reading these word problems. So I know that my formula is going to be A equals t, 1 plus r over n to the nt power, right? If I fill everything in, I get 15,000 equals 5,000, 1 plus 0.07 divided by 12 raised to the 12t power. Okay? Okay, so now I need to isolate the exponential equation. Now here, you guys, this right here, what's in parentheses, that's what's being raised to the 12t power, not the 5,000. So we can actually divide both sides by 5,000. That's gone. 15,000 divided by 5,000 is 3 equals 1 plus 0.07 divided by 12 raised to the 12t power. Step 2, take the natural log of both sides. So I have the natural log of 3 equals the natural log of 1 plus 0.07 divided by 12 raised to the 12t power. Now it's actually the natural log of all of that. And what does that do? That allows your exponent to come down and become a coefficient. So now I have the natural log of 3 equals 12t times the natural log of 1 plus 0.07 divided by 12. Okay, let me erase this.
Okay.
Okay, now this is 12 times t, 12 times t times the natural log of 1 plus 0.07 over 12. So you can actually divide by 12 natural log 1 plus 0.07 on both sides. Because what that does is that'll cancel out the 12, that cancels out your natural log, so all you have left on the right-hand side is t. And so t equals this. You just have to put this in your calculator very carefully, you guys. If you're going to put it all as one, just all together, one shot, then you need an extra set of parentheses around your numerator and extra set of parentheses around your denominator, okay? You want to make sure it's clearly top divided by bottom. And I get 15.7 years. That's how long it would take for $5,000 to grow to $15,000 if you had a 7% interest rate compounded monthly. Okay, I wanted to show you one more problem that usually gives my students some issues, so I wanted to show it to you. The question is, how many years are required for an investment to double? In value if it's appreciating the rate of 7% compounded continuously. Okay? I think I spelled that wrong. Probably. But, okay, you get it. Okay, so how many years for an investment to double? 7% rate compounded continuously. So compounded continuously, you already know we're going to use per, right? You know that the rate is 0.07. It's asking how many years, so you know that the variable you're looking for is t. Well, what's p? What's a? We weren't given that information. Well, it's really, you guys, because it doesn't matter. It just wants the investment to double. So let's say John said, well, I'm going to start off with $500. Well, that's cool. Then you're going to make, if you want it to double, then that means your A has to be 1,000. You have E 0.07 T, right? Now let's say Lucy was like, well, she wanted to choose $100 for her P. Well, if she wants it to double, that becomes $200 over here, E to the 0.07 T. Okay? You could choose any number you want for P as long as your A is doubling that amount. Why? Because here's step one. Everything's filled in. Okay? Step one is to isolate the variable. Let's see what happens when you isolate it. I'm going to divide both sides by 500 for John. That's gone. 1,000 divided by 500 is 2. E to the 0.07t, right? Lucy chose these numbers. If she divides by 100, she's still going to get 2. And now y'all have the exact same problem. So there's still only one t value. It doesn't matter what you chose for p as long as it doubled. Okay, because from here on, you're going to have the exact same work. All right, so go ahead and finish this problem and see if you come up with the right answer. What's step 2? Step 2 is to take the natural log of both sides. And the whole point of taking the natural log of both sides is so that your exponent can come down and become a coefficient. Let me get some room here. So then that gives me the natural log of 2 equals 0.07t natural log of e. We know the natural log of e is just 1, so go ahead and divide both sides by 0.07. T equals 9.9 years. All right, I hope those examples were helpful. Just let me know if y'all have any questions. Have a good evening.